Well, students, after covering the MCQs, the review questions, and the conceptual questions, I hope that you have built up sufficient knowledge of the formulas and of the concepts of geometrical optics. So now we move on to the numerical problems. The first numerical problem, most of these numerical problems will be using the formula 1 over f, that is the length equation or the length formula. 1 over f is equal to 1 over p plus 1 over q. The second formula which is mostly being used is the height of the image or height of the object is equal to distance of the image from the lens and distance of the object from the lens. Hi over ho is equal to q over p. This is the second. Third, in only one formula, and in one numerical, this formula sin I over sin r is equal to the refractive index, which is the Snell's law, has been used. So now coming to the first numerical, 12.1. This says an object 10 centimeters in front of a convex lens, in front of a convex mirror, forms an image 5 centimeters behind the mirror. What is the focal length of the mirror? So he has given you the distance of the object from the lens and the distance of the image from the lens. You have to find the focal length. So you have to use this formula 1 over f is equal to 1 over p plus 1 over q, taking care about the sign convention. The next one is an object 12.2. An object 30 centimeters tall is located 10.5 centimeters from a concave mirror with focal length of 16 centimeters. Where is the image located, and 2, how high is it? So in 12.2 you will be using this formula. First of all, 1 over f is equal to 1 over p plus 1 over q, and then you will use the second formula, image height over object height is equal to q over p, or hi, where I is in the subscript, over ho is equal to q over p. Use these two formulas to find out. 12.3. An object and its image in a concave mirror are of the same height, yet inverted when the object is 20 centimeters from the mirror. What is the focal length of the mirror? 12.3. So use this formula 1 over f is equal to 1 over p plus 1 over q. 12.4. Find the focal length of a mirror that forms an image 5.66 centimeters behind the mirror of an object placed at 34.4 centimeters in front. Is the mirror concave or convex? So find out from this 1 over f is equal to 1 over p plus 1 over q, and then from the answer try to find out whether it is positive or negative sign convention has been used, and positive is for which ones? Convex lens, and negative is for concave lens. 12.5. An image of a statue appears to be 11.5 centimeters behind a concave mirror with focal length 13.5. Find the distance from the statue to the mirror. Again use this formula 1 over f is equal to 1 over p plus 1 over q. 12.6. An image is produced by a concave mirror of focal length 8.7. The object is 13.2 centimeters tall. So the height of the object is 13.2 at a distance of 19.3 centimeters from the mirror. And distance is p is 19.3 centimeters. A. Find the location and height of the image. B. Find the height of the image produced by the mirror if the object is twice as far from the mirror. So use this formula 1 over f is equal to 1 over p plus 1 over q, and hi over ho is equal to q over p. 12.7. Nabila uses a concave mirror when applying makeup. The mirror has a radius of curvature of 38 centimeters. Radius of r is 38 centimeters. A. Find out what is the focal length of the mirror. B. Nabila is located 50 centimeters from the mirror. Where will her image appear? C. Will the image be upright or inverted? For 12.7 you have to use these formulas. Now the focal length is always half of the radius of curvature. So f is equal to r over 2, and from here use second formula 1 over f is equal to 1 over p plus 1 over q, and then the magnification factor m is equal to q over p. Use these three formulas for finding out the results. 12.8. An object 4 cm high is placed at a distance of 12 cm from a convex lens of focal length 8 cm. Calculate the position and size of the image. Also state the nature of the image. 12.8. So use this formula: 1 over f is equal to 1 over p plus 1 over q, and the height of the image divided by the height of the object is equal to the distance of the image from the lens divided by the distance of the object from the lens. 12.9. An object 10 centimeters high is placed at a distance of 20 centimeters from a concave lens of focal length 15 centimeters. Calculate the position and size of the image. Also state the nature of the image. For 12.9, first we will use this formula: 1 over f is equal to 1 over p plus 1 over q. Then you will use this formula: height of the image over height of the object is equal to q over p, and you will get the answers. 12.10. A convex lens of focal length 6 centimeters is to be used to form a virtual image 3 times the size of the object. So the image is 3 times the size of the object. Where must the lens be placed? Use this formula: 1 over f is equal to 1 over p plus 1 over q. 12.11. The ray of light from air is incident on a liquid surface at an angle of incidence 35 degrees. Calculate the angle of refraction if the refractive index of the liquid is 1.25. Also calculate the critical angle between the liquid dash air interface. So use this is the only form numerical in which Snell's law is being used. Sin I over sin r is equal to the refractive index n. Use this formula. 12.12. And for critical angle, you will be using this formula: sin c, sine of the angle of critical, is equal to 1 over n, or c, critical angle, equal to sine inverse 1 over n. 12.12. The power of convex lens is 5d. At what distance the object should be placed from the lens so that its real and 2 times larger image is obtained? For this, use this formula: P is equal to 1 over f. The power of the lens is equal to the inverse of the focal length, and 1 over f is equal to 1 over p plus 1 over q. Okay, now there are some other, some solved information which has been given in the blue boxes in the books, and let us go over these questions also, because they can also come in the examination. The first one is on page 40. On page 40, this talks about the solved box information. On page 40, you have this thing: in large points to ponder. Page 40, points to ponder. In large shopping centers, convex mirrors are used for security purposes. Do you know why? Now, what are the, you have to give reasons for using convex mirrors. So the reasons are: answer, to see hidden places. Number 1, there are some corners where you cannot see clearly and the shopkeeper cannot find out what is happening over there, so he can see those hidden places. 2, he can prevent stealing of things if somebody is over there. And number 3, for better supervision of his employees as well as the customers. The next thing, question is point to ponder, is on page 42. This on page 42. He says, why is the position of fish inside the water seems to be at less depth than that of the actual position? This is again the same type of question that we did earlier. This is regarding why. Because of the apparent depth and the actual depth. That the refraction phenomena actually bends the rays, and that is how it happens. Position of fish inside water seems to be at less depth due to refraction of light at surface. And I had drawn the diagram also earlier for you. Over here also he has tried to explain. On page 43, you have a self-assessment. Inside a box, he says whether the bending of light will be more or less for a medium with high refractive index. Now this question is regarding how does refractive index affect the refraction of light. So the question is, bending of light is more for a medium with high refractive index. If the medium has a high value of refractive index, then it will have the bending of light will be more. Now we go on to page number 54. There is another self-assessment on page 54, which says where a pen is placed in front of a convex lens if the image is equal to the size of the pen. At what position in front of a convex lens should a pen be placed so that the image obtained is of the same size? What will be the power of the lens in diopters? So page 54, place at 2f and twice the focal length from convex lens, you will get the image of same size inverted and rear. Now page 59. Page 59, it talks about he says how the size of the pupil of our eye will change in dim light, in bright light. So in dim light, the size of the pupil increases because it increases so that more light can enter inside the eye. In bright light, it decreases, it contracts so that less light should enter. And the power at 2f, this question is about the second part of it. The power in diopters at 2f. F is equal to 2 meters because power is equal to 1 over f in meters. So 1 over f in meters power means 1 over 2 diopters is equal to 0.5 diopters. This is a continuation of this self-assessment on page 54. Okay, with that we finished the book. There are some more boxes inside it which talk about some information for you. Please go over them also and try to clear the concept. If you have any difficulty, please call me. I am available at the numbers that I have given you, 0333 551 6358 and 0336 547 3312. You can call me. Only few boys have called me. I would like that others should also come up, no matter what the time is, and don't feel embarrassed by asking a silly question. Anything is welcomed, and I'll be more than happy to answer it. Assalamu alaikum.